Hello, this is Jack Jackson. In this playlist, we're going to be talking about mathematicians and mathematics of the 19th century. As I always like to do, I want to lift up some of my main sources for this playlist. Once again, I want to thank Dr. Todd Timmons, my friend and colleague who taught the History of Mathematics course at our university for many years. He has a PhD in mathematics history, and he graciously let me use a lot of his materials and help me prepare these. Of course, I also worked a lot on my own. My main sources were two textbooks, A History of Mathematics by Carl Boyer and History of Mathematics, an Introduction by Victor Katz, and the MacTutor History of Mathematics. I strongly encourage you, if you're interested at all in math history, to start looking through the math history stuff on MacTutor. It's a good, nice, free, easy, available resources. And then, if you're still interested, dive into one of these textbooks and get to know a little bit more. I'm just trying to give you a cursory overview survey in these lectures, but there's a lot more that you could dive into and see. Um, it's easy to go down a rabbit hole and just investigate all kinds of cool stuff as you get working through this history. So in this video, we're going to talk a little bit about an overview of the 19th century. And so let's talk a little bit about mathematics prior to the 19th century. The pace of mathematical creation, discovery, development, whatever you want to call it, generally increased over time. The development of the earliest mathematics in various ancient cultures took place over thousands of years, and the golden age of Greek mathematics established mathematics as a rigorous intellectual endeavor and setting up geometric proof and as the foundation of mathematics. That took a millennium, 1,000 years, 10 centuries for that to take place as that developed. In the Islamic age of mathematics, we had some fantastic growth there too. It happened over a little bit shorter period, but still last several centuries as they developed algebra and arithmetic and algorithms with Hindu-Arabic numerals and laid the foundations for what we would now call, like college algebra. A lot of that happened in the medieval period. In the Renaissance period, and just after that in Europe, lasted a few centuries as they brought that forward and brought forward a lot of the ideas from earlier cultures and brought that together and advanced it. But the pace of mathematical creation, discovery, and development was just really getting started good. It started to really increase. And as we just studied in the last couple of playlists, the 17th and the 18th centuries were very remarkable for their creation, particularly of analytic geometry and calculus. For this 200-year period, much shorter period than earlier, we had built up the discovery of calculus, the build up to it, then finally the creation of calculus, and then the subsequent expansion for 100 years of calculus techniques and their application to the physical sciences. This was really the crowning achievement of millennia of mathematical growth. Meanwhile, the concepts of the scientific method, the age of enlightenment, the age of reason, all those things kind of work together hand in hand to change the intellectual mindset of the world. The fundamental view of the world had changed to general acceptance that scientific approaches could probably be applied to solve many, maybe even most of the questions facing the world, certainly the ones dealing with physical sciences at least. And mathematics became the language of this intellectual revolution. However, in spite of over 100 years of growth and established utility of calculus, there were some theoretical problems with the foundations of calculus that still remained at the beginning of the 19th century. Mathematicians spent the next several decades shoring up those foundations. The 19th century has been characterized as the age of rigor in mathematics. Several amazingly advanced mathematicians and really talented mathematicians pushed forward the foundations of mathematics, and then they opened up entirely new branches of new mathematical study. There was actually more significant mathematical growth in the 19th century than all the previous centuries combined, at least in some ways of thinking about it. So mathematical growth had really taken off. And we can't really talk about the 19th century, the 1800s, without really talking about the technological growth during that century as well. If you take a person from way back 1000 BCE, or take Archimedes or Euclid, and if you had a time machine and could pluck them out and drop them in 1800, or especially right before that, say the time of the American Revolution, uh, they would see some changes for sure, and they would find some things that were cool, new things, a printing press, for example. And some, cities were bigger. There were advances in some areas. I mean, they had guns, but really still wars were still largely fought with swords and bayonets. They would still basically see life like it was before. I mean, basically the same kind of weapons, still just a little bit more efficient way of doing projectiles in the war, and we were still basically an agrarian society, so agriculture was actually a lot like it would have been before. Life on the farm would have been very recognizable to them. They were powered by humans, horses, oxen, mule. Ground transportation, like it was for millennia, was still by foot or by horse. We still had ships, and they were still powered the same way by sails, by wind, or by oars. But this could not be said of 1900. You could say that about 1800, but not 1900. In that one single century, from about 1800 thereabouts to about 1900, there were so many technological advances that took place that life in 1900 would have been unrecognizable to say Archimedes, and even unrecognizable to someone who had even lived about even as close as a century before. The Industrial Revolution was going on with a much more sustained concentration of the population in larger and larger cities. Mass production became commonplace. Assembly lines and machines made factories commonplace. And we had power. We had steam power and even electric power by the end of the century. We had farm machinery powered by steam, electric, and internal combustion engines. Transportation became much faster and more dependable with steam powered locomotives and ships. And we even had hot air balloons we had taken to the air. Communication expanded significantly as well. Now, for sure, the printing press was a major advancement, and that was several centuries earlier. But the telegraph and the telephone were invented, the light bulb was invented, and much more. And furthermore, this growth was unprecedented, and so therefore was completely unpredictable. Certainly, for example, the 20th century saw an even greater rise in technology, and by that time, people were expecting rapid advances. This transformation of our way of life that took place in the 19th century really took everyone by surprise. No one could predict it. And all of this technological advancement was made possible by the advancements in mathematics, which drove advancements in science, which drove advancements in engineering and inventions and technology. Um, Todd Timmons has written a book about this growth of technology in the 19th century, and I encourage you to take a look at that book. It's really fascinating. And mathematical growth during the 19th century was no less remarkable. Now let's think back. At the end of the 18th century, what do we have? We have elementary algebra and calculus had been firmly established. To the synthetic geometry of the Greeks had been added a layer of analytic geometry joining algebra and geometry. We learned had to do things like a Cartesian coordinate system and graphing functions and so forth. Modern notations and concept were mostly in place, particularly after Euler. A lot of our ideas of function, how that notation, our notations for not only just our number system, but also basic operations and equations and so forth, were pretty much in place by the end of the 18th century, the start of the 19th century. We also had research journals that had been established to disseminate mathematical knowledge. So we had a pretty regular way of getting knowledge out there. Of course, printing press had been around for quite a while, so people could publish books and pamphlets, and then also these research journals. Universities had become centers of learning, and there were lots of them around, not just one, but several of them. And there were other schools and even things like, lower schools, more like what we would now call elementary and secondary schools, were starting to prop up more commonplace. And they needed textbooks, and those textbooks were becoming commonplace. Mathematics before that, a lot of it was in sort of research pamphlets, monographs, and so forth. And but now we had textbooks that were written for more normal people to study, and then also for aspiring new mathematicians to study as well. And the new fields of probability and expansions of geometry had at least been started. And so the modern age of mathematics was up and going, and it was going strong. And so the stage was set for even further rapid mathematical growth in the 19th century, and boy, did it happen. During the 19th century, the field of real analysis was established. You might also call that the theory of calculus or advanced calculus. And that was established, firmly established, providing the rigorous foundations for calculus and related mathematics from the previous 2 centuries. Um, Arthur Cayley was uh, not Arthur Cayley. Cayley was excuse me. Arthur Cayley was important, but it's Cauchy that actually established that. Uh, Cayley did some important work in abstract algebra a little bit later on. But anyway, that was established by him and others. And that helped provide a rigorous foundation for calculus. And so that and related mathematics from the previous 2 centuries, putting that on a much firmer foundation. Rigorous proof was brought to the forefront. And then on top of that, they even layered even entire new fields of mathematics, often with more and more abstraction. And so the age of modern pure mathematics had arrived. So we had not only real analysis, but complex analysis, extending calculus into what if we allow complex numbers for inputs and or outputs. And then a new area of abstract algebra, working with things such as groups and rings and fields. So algebra, of course, what I would call maybe elementary algebra now, what you might call things like what we might call college algebra. A lot of that was known back to as far as the Islamic mathematicians in the House of Wisdom, for example, and then added on to throughout time in the Islamic culture and then in Europe. And then the notations became more commonplace later. But abstract algebra is a little bit different. It is taking those basic ideas of, say, numbers and operations and extending them in a more abstract setting and applying them to things like permutations and matrices and other types of things that operate somewhat like numbers with addition and subtraction and so forth and multiplication, and taking those things and seeing what algebraic properties we can find and work more abstractly with that. And that came along it really came along more in the really came matured in the early part of the 20th century, but the groundwork for that and the first foundations of all that really happened in the later part of the 19th century. We also had differential geometry, and non-Euclidean geometry was discovered. Once they found non-Euclidean geometry, hyperbolic geometry, that was a revolutionary paradigm shift in the way we thought about lots of mathematics. Topology was also getting its start in that century. Set theory, Cantor basically created the whole field of set theory pretty much on his own, and that came about in this century. Other things like linear algebra, and then some more applied areas of mathematics too. Probability and statistics really started to get going. A bunch of things about statistical analysis, least squares regression, and some other things we're starting to bring to the forefront. And notice a lot of this mathematics is now mathematics for mathematics' sake, mathematics for its own sake, mathematics as an art form, mathematics that was pure mathematics where it didn't need to be applied necessarily. It wasn't necessarily motivated by real world applications, although in some cases it was, but it kind of stood on its own. But there are also, of course, applications of mathematics. Mathematics continue to be applied to many fields, to the physical sciences, and with statistics started being applying to other areas as well. And that motivated some additional mathematical growth in different areas of applied mathematics. But we also had mathematics more for its own sake as well. And there are many more more types of mathematics. But as things went on here, we've got more and more abstract in some of the mathematics, or a lot of the mathematics that was going on in the 19th century. And
mathematics became more and more specialized. By the time we got to the end of the century, mathematics had grown so much that there was no longer possible for any one person to really understand and do all of it. Um, you had to start to specialize a little bit more. And if you look back into the earlier centuries,
If you look at the greatest mathematicians of the earlier centuries and the greatest scientists, they were the same thing. In some cases, they were called maybe natural philosophers before they started using the term scientists. Uh, but basically, those were the same people doing a lot of that work in many cases, at least. But as we go through the 19th century, there's still a lot of that. A lot of the folks doing the highest level mathematics are doing the highest level science as well. But that becomes a little bit less and less as people start to get a little bit more and more focused, where there was more and more people who were able to spend pretty much all of their energy working on just mathematics and others, more just science. And so we start to see a divergence of people specializing, and that would continue a little bit more, a lot more into the next century. But the 19th century really set the stage for the way we think about modern mathematics. Whenever I, for example, got my PhD and working in pure mathematics. The main four areas of pure mathematics were real analysis, complex analysis, topology, and abstract algebra. And all of those, if they didn't get their start in this century, they either started in the 19th century and got really going there, or they were really came um, to maturity in some ways in the 19th century. So, um, pure mathematics really became the output of the 19th century, and we had this massive, amazing uh, uh, expansion of mathematics. Okay, and what I hope to do in the next several uh, videos in this playlist is show you a little bit about some of the mathematicians that were involved in this process and some of the mathematics that they did. And we'll start with maybe the greatest of all of them, Carl Gauss, in the next video.